OneTest embedded integration. And then I will switch to a different Eclipse. This is RTist 11, as you can tell from this quick access field up here. So I think in last sprint demo you already saw a bit how this works, but to recap a bit how it works is that we have a model and a transformation configuration, and what I did when I wanted to instrument this is that I right click and do OneTest embedded instrumentation. I then have to specify something called instrumentation project, which is in my case is this OT instrumentation pro. It basically is a container for where the results from the coverage analysis would be put. And then you can choose whether you want to update only this TC or its prerequisites too, or maybe get prompted each time you build. So now I've already done this, and the result of doing that are some additional settings that you can look at here in the code tab. We don't need to go into exactly how they work, but you can, for example, see that this project here is passed to RTist CC, which is the compiled driver used by OneTest embedded for instrumenting the application. So I think I have already built it, but I can just in case build it again. And building will of course take a bit longer when you have instrumentation, since all C++ code will be pre-processed by OneTest embedded. But now it was already done, so it was of course very quick. And so then the next thing is that you may want to do is to run some tests on this application. And this particular sample here is a very simple application that computes a numeric value for pi using some state machines. And you can run it just like this. In a more realistic scenario, you would maybe have some test suites that would run your application with various inputs to get a good coverage. But for now, just let's run it once here. And each time we have run it, we will get results in this instrumentation project. But to see them, we first need to refresh, and we get this SPT file, which is a binary file containing not only coverage, actually, it's lots of other things that OneTest embedded computes for problems in memory leaks and performance and other things that you can read about in the OneTest embedded product presentation. But for our need, when we want to look at this as a coverage, we need to run this command, create application result. This will essentially just invoke some command line utilities that will process this file. And if you would integrate this into your automated testing, you will of course use these command line tools directly instead from the command line. And then when we've done that, we get the result here in application results. So now you see this is the timestamp when the application was run. It was run just a couple of minutes ago. And as you can see, I've also run this application several times before. You can imagine that those runs would have been for different test arguments to test the applications in a different way. And to open the coverage, just double click on that file, and you then first will see it in this coverage viewer. Here we made some improvements since last sprint. So, for example, we have added checkboxes so that you don't need to open everything at once. Because what you typically want to do here is that you want to sort here on coverage count and find the ones that don't have any coverage. So this means that there is one transition here which execution of this application didn't trigger. And then of course it can be interesting to look at only this diagram and not everything else. And here we see it's an initial transition, and we can quite clearly see why it doesn't execute, because this is a nested state that is always entered through this T1 transition, and we never actually we don't need this initial transition, and we could just as well have deleted it. So that's one way this feature can be used. The other is the opposite, and that is to look at the ones with the most coverage, because here, for example, you see that this state gets entered 101 times. So it's of course quite important that you don't have any code that takes a long time in the entry action of that state, and the same for those other transitions. But quite often it's not enough to just look at one execution result. You more likely would like to look at many. So if you have, like in this case, 5 executions that you have done representing various tests of the application, you can then right click and do this open with the coverage viewer to open the combined result. And now you see the coverage count gets accumulated for everything. In this case, executions were identical, so it means we just multiply everything with 5 here. But it can be, of course, more interesting if you have some real application that will real data and real test cases. Yeah, I think that basically concludes what I want to say about OneTest embedded integration. Do you have any questions?